Now let's look at some curves of degree 3, or cubic curves. 3 examples reveal the basic properties of all cubic curves. Y equals x cubed, y equals x cubed plus x, and y equals x cubed minus x. Each curve has 2 parts, one that bends down and one that bends up. The place where the upward and downward parts meet is called a point of inflection. The basic shapes don't change if we add a positive constant to move them up or a negative constant to move them down. In each of these 2 examples, the graph crosses the x-axis at exactly 1 point, even when the graph is moved up or down. But in this example, the graph crosses the x-axis at 3 distinct points. Adding a constant doesn't change the shape, but it can change the number of zeros from 3 to 2 to 1. These 3 examples, y equals x cubed plus x, y equals x cubed, and y equals x cubed minus x, can be regarded as the prototypes of all cubic curves. Let's see what happens as we change the coefficients in the equation of a cubic curve. Although the shape changes, it has the same basic form as one of the 3 prototypes. Or perhaps a mirror image. Every cubic crosses the x-axis at least once. To see why, factor the cubic as the product of a linear factor and a quadratic factor. The linear factor has exactly 1 zero, which is also a zero of the cubic. In this example, the quadratic factor is never 0, so the cubic has only 1 zero. In this example, the quadratic itself has a double zero, so it can be factored and the cubic has a triple zero. Finally, in this example, the quadratic part has 2 distinct zeros, so it can be split into 2 linear factors. And we see that the cubic is a product of 3 linear factors and therefore has 3 zeros, one for each linear factor. This is what a cubic looks like if the 3 zeros are distinct, no matter how far apart they are. To understand why, let's follow the 3 factors from left to right. In this region, all 3 factors are negative, and the cubic takes negative values. Here, one factor is 0, so the cubic crosses the axis. Here we have 1 plus and 2 minuses, so the cubic is positive. Here the second factor is 0 and the curve crosses the x-axis again. Here we have 2 pluses and 1 minus, so the cubic is negative. And here the third factor is 0 and the cubic is 0. After that, each factor is positive and the graph continues to rise forever. Somewhere between the left 2 zeros, the curve has a turning point or a peak called a local maximum. And there is another turning point or a valley between the right 2 zeros called a local minimum. Now let's see what happens when these two zeros are made to coincide, or when these two coincide. A more dramatic change takes place when all three zeros coincide. The peak and valley come together at a point of inflection. Computer-aided design uses pieces of polynomial curves to trace out shapes. For example, if you take two cubic curves and plot one against the other, you get a more flexible curve, just the sort of curve you need to make a teapot.